Thanks for tuning in. In this video, we will discuss our question 9 for this prelim examination in Nepal this year, September 2022. So question 9 is a question on the electric circuit. So the electric circuit below, siyabona ukuthi basiphe a battery with an internal resistance of 1 ohm, a closed switch, sine current A1, A flower on the lower branch of this parallel connection, and then A2 flowing through the upper branch of the parallel connection. Ngichaza ukuthi R, the resistor R, is parallel to 6, 12 and 20 combined. So the combination of these resistors is parallel to R. So hence A1, which is current for the lower branch, A2 is current for the upper branch or the second branch, right? Let's say no 6, no 12, which are parallel, and then no 20 la, right? So just a quick explanation before sizophendula lama question. And then another thing, specify a current of 0.5 amperes which passes through the 6 ohm resistor. So I see note la. So sizoti 0.5 amperes current flowing through 6 ohm. Flowing through the 6 ohm resistor. So now lana, this is just a portion of the circuit actually. So ngithatha lama resistor lawo. Ngifuna uku-explainer the network ukuthi uyitreat kanjani, or how you were supposed to treat it le network le. So lana, this is R, nangu R wakho, nangu A2, A1, 6 ohm, 12 ohm, 20 ohm. It's basically the same as this one, right? So bheka ke into engifuna ukuyi-explain, ngizofuna ukuyiqala ukuyi-explain la ukuthi this parallel connection ka 6 ohm and 12 ohm is actually in series with the 20 ohm resistor. So bheka ke this circuit naso calculate the total resistance yalana, ngizothola something efana na this, or circuit yami iba like this. A1 kusese nguye, A2, the parallel connection, the total resistance of the parallel connection is in series with the 20 ohm resistor. So basically that's the idea lana, right? So lana siyayibona ukuthi it's a parallel connection, and then ngithizeni a combination of lama resistor lawa I3, they are in fact parallel to bani R. Why is that true, right? Why is that true? Why is that true? So bheka lana again, bheka ke la. So current A naga flower, this is a branching point to current A uzo splitter between 6 ohm as well as 12 ohm. And then where current is splitter corner, it simply tells us no, lana there's a parallel connection. So the same thing happens with A2. A2 ungena ngapha ku R, and then another current to A1 ungena kuphi on the lower branch as well. So it means the R and this lower branch are parallel. So lana again, since this is a series connection, 20 no RP is a series connection, it means that la A1 uzoba common kule parallel connection as well as the 20 ohm. Now 9.1 asiqale ke siphendule ama questions where to. So now ku 9.1, Ohm's law. What is state Ohm's law in words? Simdefine ngale ndlela le. So it's important, even if nanoma uzobhala final exam yakho, make sure ukuthi uyawazi ama laws wakho. Every law uyakwazi ukwa-define. Lichetlia's law for chemistry, Ohm's law, knowing how to define ama terms are important, like abu EMF, abu concentration, into ezifana nalezo nje, yabona. So lana I expect ukuthi everyone uyi-collectile these 2 marks, right? Now siya ku 9.2, 9.2.1. Now go 9.2.1 but calculate the reading on A1. So A1 so calculator kanjani ke. So bheka ke the idea la ukuthi si calculate i-current, right? A1 u-A1 common kuphi ku parallel connection as well as ku 20 ohm, meaning the current eflow la kule parallel connection izoba the same as the current eflow ku 20 ohm, since the parallel connection and this one are in series, and in a series connection current iba constant, right? So yini into constant in a parallel connection konje? It's what? It's the potential difference. So in order to calculate to A1, I need to calculate I need a potential difference either la ku parallel connection or la. So since the 20, there's nothing much we can do lana, since I was paying current they flow through the 20. If basiphe yona bezofana neka A1. So now the current eflow la ku 6 ohm izoba useful. Now just apply Ohm's law ke manje, ne? V, which is the potential difference ku parallel connection, is the same. So current potential difference ku 6 na ku 12 izoba equal, and izoba equal to the whole network as well, right? So bheka ke V is equal to current times the resistor for the 6 ohm resistor. Now I is 0.5 is calculated the potential difference for 6. So it's 0.5 times 6. Answer is 0. It's 3. It's 3. Answer. It's 3. It's 3. It's 3. So answer lana is 3 volts. So this 3 volts, it's for this 3 volts. It's for bani. It's for 6, and then the 3 volts is also for 12 because this is a parallel connection, and it's also for the entire network, the entire parallel network. So the potential difference lana, it's also 3 volts, right? So in order to calculate to A1 is common for the parallel connection as well as the 20 ohm resistor, right? So for the parallel connection saying the potential difference, if I can find the total resistance for this parallel connection in a voltage line, I can calculate the current, and this is over equivalent to A1. 90 so yenza again. Into yokuqala so yenza so calculate the total resistance for the parallel connection. So 1 over Rp is equal to 1 over R6 ohm plus 1 over R12 ohm. So this is equal to 1 over 6 plus 1 over 12 equal to 1 over 4. Let's see 1 over 6 plus 1 over 12 is equal to 1 over 4. So therefore Rp is going to be equal to 4 ohm. So it's just the Martin's flipper the numerator and the denominator, since you formulate it 1 over Rp. So Rp is 4 over 1, and 4 over 1 is equal to 4 ohm. So now since the total resistance for this parallel connection is 4, and the total voltage for the parallel connection is 3. So the current SOE calculator la is the same as A1. So current I1 is equal to V over R. So it's V for the parallel connection, R for the parallel connection. So V ubani 3 divided by parallel connection is 4 equal to current to bani. It's 3 over 4, 0.75. Yes, 0.75 amperes. So this is our answer for A1 reading 9.2.2. I think erase lana. Okay, now 9.2.2. 9.2.2. Calculate the reading on A2 when the power dissipated in resistor R is 16 watts. So now lana sebasipa ini power which is 16 watts. Now the calculation later is centered around the R resistor. Sifuna calculate the current flow through the R resistor. So since basiphe current iloganje power, it means in order to calculate current yethu we need to use the value of power since basiphe yona la, right? So sisebenzisa formula for power. I think totally formula sheet. Let's see. Oh yes, here we go. Okay, yeah. Bheka since i-resistor for resistor R anginayo, it means kuyosebenza le formula le ithi P is equal to VI ngifuna ini, yeah, okay, kuzosebenza this formula. Ngifuna calculate ini i-current. I want to calculate current. Do I have power? Yes. Do I have a voltage? Yes, in a way I do, because this is the exercise manje ukuthi calculate uV, so that we can calculate the current. I'm given the power, so singayicalculate kanjani ke i-voltage ke manje, singayicalculate kanjani i-voltage? Okay, i-voltage sizoyicalculate ngale ndlela le, so i-calculate ngale ndlela le. Since ngithene ekuqaleni the R, the 20, the 6, okay, the R and the 20, 6 and 12 combined are connected in parallel. And siyazi within a parallel connection, voltage is what is constant. So bheka, if I can calculate the voltage la ku 20 ohm, ne, the voltage is divided to series connection. So I need the voltage yala, so that we add the voltage yala. So this voltage combined is going to be the same as the voltage measured across R. Why? Since this branch and this branch are connected in parallel. So let's calculate the voltage yala nakal. So for the 6 ohm resist, not 6 ohm, 20 ohm resistor, siqale lapho. For the 20 ohm resistor, siqala lapho, so calculator ini your voltage. So V for 20 ohm is equal to current 1. The current is calculated previously, sitheni constant for the parallel connection as well as the 20 ohm multiplied by R 6 ohm. So I1 so we calculated 0.75 times 6 la. Okay, answer yethu kuyoba ubani? Kuyoba 0.75 times 6 is equal to 4.5. So answer yethu ke le 4.5, which is the total voltage measured across. Kanti ngenzani manje? What's wrong? 20 not 6. Kalo 6 ngimthatha phi? Ngisastake la. It's 20 la, not 6 but 20 ohm. So lana it's 20, right? 20 equal to 20. So our answer is 15 lana. So it's 15 volts. The answer here together, right? This is our answer now. Therefore, V total singayibizani le V total le? asithi ke V for asithi lower branch, or let's just say voltage asibhale, so voltage for the lower branch engikhuluma ngayo, for the lower branch is going to be equal to V, asinikeza igama, asinikeza iletter, a subscript of L, lower branch, equal to V for 20 plus V for the parallel connection. 20 plus, remember the parallel connection and the 20 are in series, and in series potential difference is divided. So for the 20 it's 15 plus for V total, for V parallel it's calculated as with 3, right? It was 3. 15 plus 3 is 18 volts. So this is our answer. Therefore, sesibuyela lana ke sithi V for the lower branch is equal to V for the R resistor, which is 18 volts. Therefore, let's substitute ke current uzoba equal to power divided by V. Into engiyenzile la ukumanipulate le equation le ye power, making I the subject of the formula. So P 16 divided by V is what? Is 18. Yeah, it's 18 divided by 18. So 16 divided by 18 is equal to 0.888888. Okay, izoti 0.89 amperes. So now I answer here together 0.9 amperes. So lena current A flow go R, which is current A2. Now for the final question 9.2.3, lagu 9.2.3 bafuna calculate EMF, right? EMF of the battery. Calculate the EMF of the battery. Okay, the EMF is calculated as EMF is equal to V external plus V internal. Sometimes lena bayibizana konje. Sometimes bati, okay, it's external, sometimes bati man. I forgot the term. There's something abayibiza ngayo, but if ngiyalikhumbula ngizonikhumbuza lona nami. Okay, now EMF is equal to V external plus V internal, right? So the V external is calculated as current times R, the total effective resistance for the circuit. So we are going to R siyamdinga in order to calculate the what's this, in order to calculate the external resistance, plus I small r. The small r is internal resistance here to lege. Now the internal resistance is given. I have the current for the whole circuit. In fact, the I lana will represent the current for the whole circuit. So bheka ke sithe ekuqaleni sithe lana sinani, we have a branch. So A1, A2 no A1 combined banginika the current for the whole circuit. Ngoba A2 no A1 baya split la, A2 ungena la, A1 ungena kuphi la. So nangihlanganisa A1 no A2, I get the current for the whole circuit. Ngithola AT, right? Ngithola AT. So nathi ke into soyenza I, let me say I nginayo, which is I1 plus I2 plus I2. I1 is 0.75 plus I2 is 0.89. So you calculate here. Alright, yeah, now nangizo add la ngizothi 0.75 plus 0.89 is equal to it's 1.64 amperes. So this is the total current. It's the current for the whole circuit. Ile komele sisebenzise for calculating EMF. Now ngifuna the resistor in order to calculate the total effective resistance, or the total resistance for i-circuit yethu. Now u-R singamcalculate kanjani ke? Singasebenzisa i-power for i-formula for power. Remember on the previous questions we calculated i-current eflowa la using the formula for power. Now ngifuna u-R ke manje. Let's use the formula for power. So we have the option of using the formula ATP. I think ibhale la so that ngibe space. It's either P equal to I squared R, or P equal to V squared over R. I can either use this one or this one, it doesn't matter, but mina prefer this one. Why? Ngoba i-current ingaba wrong. Ingaba wrong. I always like the idea of using given values instead of using values abang engizicalculatele mina. I know, I understand there's something called the positive marking, but that's my mindset, man. So let's use this one, P V squared over R. Even nalo R, nalo V sim calculate, but yeah, you get the point. So whether we say inside this one or this one, uzo yafana man, yafana. But mina ngithanda ukusebenzisa formula where the values are given. So cross multiplying la, making R the subject of the formula, ngithola V squared over P. So the V, it's the V for iloganje to E, it's the V for the R resistor, equal to the R resistor. The R resistor on the previous question, R resistor is what? Is 18. So therefore lana it's 18 squared divided by 16. So it's 18 squared divided by 16. Answer is 81 over 4. 81 over 4, which is the same as 20.25 in 2 decimal places. 20.25, right? Now the total effective resistance la, it's 1 over R. The total external resistance is 1 over R. Siteni, the R is parallel to the 6, 12 and 20 combined. So it's a parallel connection. So it's 1 over R resistor R plus 1 over R20 plus R parallel. The R parallel, it's this one. The 20, it's this one. Why ngba add alanga pants? It's because of this parallel and 20. It's a series connection. Divided by 1 over 20.25 plus 1 over 20 plus 4. This is equal to 1 over 20.25 plus 1 over 20 plus 4. Hey, le paper we balbopile. You. Okay. I see round it off to. Alright, I think so. So izoti 0.091, right? 91. So therefore R external is equal to 30 calculator out shift but to press this one so that you tolerate the inverse of your answer. is equal to 10.98 10.98. So nayi answer yethu ke, nayi answer yethu. This is for the external resistance. Okay, now I think erase lana. Still say okay, I think nayi summary yalama values calculated again. I total is 1.64. External resistance is 10.98. Internal resistance is equal to this. Now, EMF it is over equal to 1.64 multiplied by R external, it's 10.98 plus internal resistance 1. This is equal to 1.64 in brackets. It's 10.98 plus 1 equal to, it's 19.65. 19.65 in 2 decimal places volts. This is the EMF of the battery connected to this circuit. So i-video iphelela lana guys. So I hope ukuthi ikuncedile, iyakunceda le video ukuthi understand ukuthi the question ukuthi bungayi-approacha kanjani. In the description below ungakhohlwa, there are videos for this question paper engiwayenzile futhi. If you're interested, check them out. Yeah, thanks for watching. Don't forget to like, share and subscribe. Thanks for watching. Asibonane kule video elandelayo. Bye bye.